Assalamualaikum and hello everyone. Today we will learn about chapter 3, which is Gauss Law. You already learned in the previous chapter about how to find the electric field intensity at the specific point or regions using Coulomb's law. You also has been introduced about the analysis based on different charge system. For example, you have the point charge, line charge, and surface charge. In this chapter, you will learn how to find the electric field intensity in a regions using the much simpler approach. Right, you will be introduced about the concept of electric flux density and the relationship between the flux density and our charge system, and then the divergent theorems. The divergent theorems will show you about the relationship between the electric flux density, the charge system, as well as the charge density. Right, so what is a Gauss law? We use a Gauss law to find the electric field intensity, okay? And this method is simpler compared to the Coulomb's law, but it can only apply for a symmetrical charge distribution, which is not universal. And then we can obtain the value of E from the electric flux density, D. Okay, let's say you are given a two charge system. One, we have the positive charge at your left hand side, and then you have the negative charge at your right hand side. Let's say this charge will emit the electric flux. Right, so we have the flux E, referred to electric flux. For the positive charge, the flux will going out. For the negative charge, the flux will going in. And you can see here, if the charge has different or opposite sign, it will attract each other. When it has the same sign, it will repel each other. So here, the flux E refers to the number of electric flux lines and the directions of our electric field density, and also the electric field intensity is the same with the direction of the flux lines. Okay, going out. Okay, D is referred to the flux density. This is also a vector unit where the magnitude of D is proportional with E, or equal to epsilon naught E. Next, we go to the Gaussian surface. Alright, let's say you have a charge Q, and then we write an imaginary surface from a certain distance from the charge Q. Okay, we can say that all charge transfer to the imaginary surface through a flux line. Okay, we can say that any charge inside can be transferred to any imaginary surface or Gaussian surface through the flux lines, because the flux will emit, okay, in all directions, and we can imagine that the charge can be transferred to the imaginary surface. The total flux E from the inner sphere is total charge Q. The flux E from the inner appear equal to total charge Q. So any charge here can be transformed equally to any imaginary surface. Okay, that is the second concept. Okay, for the third concept is a magnitude of charge on the imaginary surface is equal to magnitude of charge inside the surface, or equal to Q. So all these 3 points you have to understand and remember, because this is very important to explain the concept of Gauss law. Okay, let's say for a charge system, I have a several Gaussian surface from a certain distance from the charge system. Let's say we have E1 here, and we have E2, D2, E3. So we can say here that the magnitude of E1 is basically equal to E2 because it's located at the same Gaussian surface. But the magnitude is not equal to E3 because E3 is located on the other Gaussian surface, which is far away from the Q. And here, our D field is located the same with the E2 or E1. So we can relate the D2 is equal to epsilon naught E2. Okay, next we go to how can we define the Gauss law using the electric flux density. Right, now we can see from these expressions, so basically the integration of D over the closed Gaussian surface is equal to the total flux on that surface. And the magnitude of total flux equal to total charge inside the closed Gaussian surface, or we call Q enclosed. The flux is equal to Q enclosed. So now the definitions. The Gauss law is basically the integration of electric flux density D over a closed Gaussian surface S equal to the charge enclosed the surface. So you have to understand this simple equation very well. Okay, the expression is very simple, but many students fail to understand. So you have to know what is the D, why we have to do the close integration. Okay, this is the symbol of close integration of D with the surface, and this is a dot product. The dot product between two vectors will become a scalar. And then we have the Q enclosed. Q enclosed means the charge enclosed by the Gaussian surface. Therefore, the charge outside the Gaussian surface will be ignored. We will not consider any charge outside the Gaussian surface. This is very important.